Hello, everyone. Welcome to Service Mesh Academy. I am joined today by William, our CEO over at Buoyant. I'm
Howdy.
Flynn. I'm a tech evangelist. We're going to talk today about what's coming in Linkerd 2.13. So this is how you can reach us if you are trying to find us later. Flynn at buoyant.io, William at buoyant.io. Easiest way to reach me is on the community Slack as Flynn. Easiest way to reach William is actually Twitter at WM. You know what? Let's just move aside from the Twitter thing and go on. Today is going to be a little heavier on slides than is probably normal for a lot of the other Service Mesh Academies, a little bit lighter on the workshop. It turns out we have a fair amount of stuff to cover about 2.13, so we'll get right into that. William is going to do an overview of what's coming up in 2.13, and then we're going to go into a workshop on dynamic request routing. If you are going to follow along for the workshop, which we think is much more fun than merely watching the workshop, you will need a Kubernetes cluster. I'm going to be using K3D. It doesn't really matter. You'll need the kubectl CLI, the Linkerd CLI. The demo as scripted uses the bat command. You could get away with less if you don't want to install that. And the workshop source, as always, or as almost always, is in the Service Mesh Academy repo in the sneak peek 2.13 directory. And with that, we cannot go into the demo yet. First, we have to talk about Linkerd Day.
Do we want to talk about the workshop channel real quick?
We probably should, actually. If you are on the Linkerd Slack, please join the workshops channel. That is a great place to ask questions and to get whatever information sorted out that you need. Many of us tend to be there even when there's not a Service Mesh Academy running, so it's a great place in general to find us. And there you have it, the workshops channel on the Linkerd Slack. If you're not familiar with the Linkerd Slack, you can find it at slack.linkerd.io.
I didn't even know we had a banner like this. That's really fancy.
Hey, we got the cool stuff with the shiny new video streaming technology, right?
Oh, I'm impressed.
Linkerd Day coming up at KubeCon in Amsterdam. This is the first ever Linkerd Day, which we're kind of excited by. We have a bunch of really interesting talks that are happening there. We're very proud of the fact that this is the only co-located KubeCon event that is 100% end user talks. There are no vendor talks here. And we would be delighted if y'all are able to join us if you're going to be there in Amsterdam. So with that, I'm going to hand this over to William to do an overview of what's coming in 2.13.
All right, I'm going to do my best. And I don't know if you noticed in that Linkerd Day slide, but there are some cool companies that are using Linkerd that are going to be talking.
There are.
Yeah, if you're going to KubeCon, please join us there. I'll be there. Flynn will be there. A bunch of other Linkerd nerds will be there, and we're lonely, and we need you to talk.
We need human contact because we're going to do that.
All right. Okay. So Linkerd 2.13. This is going to be a big release for us. I'm going to talk about a bunch of stuff. The two kind of real headline features are what we're calling dynamic request routing and circuit breaking, and we'll talk about those in depth. And I think when we do the workshop section, when Flynn does a workshop section, we're going to be focusing really heavily on dynamic request routing, which is what's available already in the latest Edge. Circuit breaking we'll talk about, but it's not in an Edge release yet. We're also going to be introducing FIPS support. So for those of you who are using Linkerd in situations where you're trying to run it for the federal government or for anyone else who cares about that kind of thing, we'll be shipping a 2.13 that has FIPS support, and I'll talk a little bit about that. We've got some really cool stuff coming up with Buoyant Cloud that I'll mention. And we have an Azure Marketplace offering, which I don't think I actually ended up putting slides in because there's really not much to say other than, hey, if you're using Azure, we've got a Marketplace offering, which can make some of the stuff easier for you. But if you're not, then probably not that relevant. And the big question on everyone's mind is, when will 2.13 be ready? I'm expecting somewhere between the end of March and the first week of April. So we're probably 2 to 3 weeks out now. There's some question marks in there, some asterisks, some things we still have to figure out. But if everyone in the Linkerd community could just pedal a little faster, and you should be able to get up the hill. So it's getting pretty close. We'll be there soon.
Seeing the Edge release was actually pretty cool. So
yeah, and that's right. And once these big features start, landing in Edge releases, that's when shit's about to get real. Stuff is about to get real. Okay, so let's dive into some of these features. Let's start with my favorite, although I guess Dan Williams is really excited about circuit breaking judging from the Workshops channel. Dominic asks if we're going to have a 2.13 celebration at KubeCon. Yes, we're going to have a massive celebration. It's BYOB. So just come to the find us at the
by the Linkerd booth and
right.
we'll celebrate.
Yeah, and bring a beer and we'll party. Okay, so let's talk about dynamic request routing. So the goal of this feature is I want to have full control over the requests in my cluster. So let's start with what's available today in 2.12 and in a bunch of earlier releases. The way that you did any kind of request routing, I mean, typically, this is technically all dynamic request routing. Was you would use traffic splits, right? And that's something that originally were part of the core Linkerd. We ended up moving them into the SMI extension at some point, right? And that's kind of your primary tool today. And what they give you is coarse-grained routing behavior. So it is dynamic, right? You can update these traffic splits on the fly. But basically you have kind of two things you can tweak. You can tweak the service name where the traffic actually is going to land. And then you can tweak what percentage of traffic to split. So that's, pretty powerful. And you can do things like, the two common cases we see are progressive delivery and multi-cluster. So progressive delivery, you could use a tool like Flagger and you can say, okay, I'm launching a new service, foo-new. So rather than just flipping all the pods over there, I want you to route 1% of traffic to this new service. Let's monitor its health. If it looks good, let's increase it. Okay, now 2%, now 10%. Okay, now we're at 100%, and we can delete the original foo implementation. So super cool. All that you need is percentage and name. The other big use case for traffic splits is for multi-cluster. So when you create a multi-cluster kind of mirrored service is what we call it, it gets a name like foo-west. And if you want your local traffic to be able to talk to foo-west but not know about it, your local services, you put a traffic split that basically acts as an alias. So you say 100% of traffic to foo should actually go to the thing called foo-west. And then that gives you, some primitives around or some capabilities around, okay, now I can do failover, I can control that thing dynamically. Maybe foo is actually a local version. And then when something fails, I change the traffic split so that it's sent to somewhere else. And we've got some control logic around it. So you can get very fancy. But that's the state of things as of 2.12. So now let's talk about 2.13. Okay, so now we are going to not just talk about the host header effectively, or the authority header. We're going to talk about almost every attribute of the request. We're not going to look at the body because the body is still off limits, but headers, verbs, anything else in these HTTP requests, including gRPC requests, will be available for us to do routing on. And the way we're going to do this is we're not going to use SMI. We're not going to use traffic splits. We're going to use the good old HTTP route object that you are probably familiar with if you've done anything with authorization policy in 2.12 or later. We're going to use that thing as the kind of core configuration primitive. And that's a very powerful, very expressive, very complicated in a lot of ways tool that Flynn is probably, a little too familiar with at this point as our representative in, a lot of the gateway API conversations. But this is going to be our core tool, not just for authorization policy, but for doing this kind of fine-grained dynamic request routing. And this means we can now do stuff where we route traffic based on any of those components. You can pull out portions of the path. You can get very sophisticated. So that gives us the ability to do things like sticky sessions. It gives us the ability to do things like per user canaries. So instead of saying 1% of traffic comes over here, we can say, hey, every user ID that, starts with a 1 or ends with a 1 comes over here, right? We can do sharding across regions. We can do anything we want. Now, there's some nuances in here. There's some, some asterisks in here And as you go through the demo portion, I think you'll get a sense for, what you can do and what you can't. You can't really do real computation in here. So you can't say, okay, take this path component out and then like add 7 to it and then look it up in this hash table and then, blah, 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 right? HTTP route is basically a set of matching rules. But that kind of computation, if that's what you want, you can put that in your application, right? And then have it emit as a header, and then you can build your routing based on that header. So, very flexible, very powerful, but not like arbitrary computation. Does that jive with you so far, Flynn?
So far, so good.
All right. You want to take us through this very boring example, which is
It's kind of boring. Yeah, so this is a simple example of what a route would actually look like to do a Canary deployment. And we'll see a little bit more about this in the demo, but the main points here are the main things to be aware of really are you need to be careful with the namespace. In general, the route needs to be in the namespace as the services it's modifying. You need to be careful to match up the port numbers with the ones that are defined in the service resource, but then you get to do things like say, so traffic coming into my color service, I want you to split it 50-50 between the pods belonging to the color service and the pods belonging to the color 2 service. So this would be a really simple 50-50 split between 2 different versions of hopefully the same service. Simple.
So this is something you can do with a traffic split today, is that right?
That is correct.
Okay, so this is like porting that to HTTP route. Okay.
The kind of header-based match that William was talking about a second ago that we might use for an A/B test, for example, you keep the same object, but you throw in this HTTP route matches object. So this particular one will be, if you see a header with the name x-faces-user, and this is all case normalized, so you don't have to worry about that, and it has the exact value of test user, then route that to the pods that belong to the Smiley2 service. Otherwise, route the request to the pods belonging to the Smiley service. And that gives you a lot of flexibility to be able to match on things that are not just the name of the service or the name of they're not just the name of the service or a percentage of weight. You get to do more sophisticated things than that.
And this is something you can't do in traffic split.
That is correct. Nothing in Linkerd prior to the Edge release that we're working with today can do this at all.
Okay.
So that's pretty cool. All right.
Yeah. So some notes on the gateway API. I mean, Flynn really is the expert here. I'm just going to be the person who likes to talk. So for those of you who remember kind of our announcements around 2.12, that was the first time that we really embraced the Gateway API. Gateway API is a new set of APIs they're in Kubernetes land, right? They're on your cluster today if you have a modern version of Kubernetes. And they were kind of designed as a replacement for the Ingress API, which was kind of this perennial, poor, unloved portion of Kubernetes that was never sufficient for actually doing Ingress. So, at some point, smart folks sat down and said, okay, let's build an actual API that can actually handle the full intricacies of Ingress. And the design was pretty good. It was so good that actually a lot of it makes sense for the service mesh too. There's this ongoing project called the Gamma Initiative, which sounds, very forbidding, but really it's just like Flynn and some of his friends, trying to adapt this to to the service mesh use case kind of like more directly, but it's pretty close, right? It's pretty close. And in 2.12, we kind of embraced that, as I said, for authorization policy. Here we're using it for for fine-grained routing. It all solves this really thorny problem for Linkerd, which is how do we allow you to express like arbitrary classes of HTTP traffic, right? Because that's what we need to do for a lot of features, right? So it's powerful, it's flexible, it already lives on your cluster. We actually are doing something a little naughty, which is we're making a copy of that CRD into Linkerd space for like long, boring reasons that are not worth getting into. But in the long run, we'll use the core resource. I expect all of this stuff to deprecate SMI in the long run. I also expect this new approach to deprecate service policies in the long run, but they're not deprecated in 2.13, and they're gonna these two ways of doing things are gonna kind of live together for at least one more version. There's a question from Nicholas in the live chat here. Yeah, can you do canaries by content of the cookies header? Yes. Yep. You can match the contents within there. Now, the cookies header is going to be, what is that? Is it like some base 64 encoded something?
It's potentially a little weird, but it is possible to do matching within it.
But you wouldn't be able to like base 64 decode the header like in
no
route.
Yeah, no, you would. I mean, there's a lot of utility just doing things like if this user has a cookie with this name, which is a fairly straightforward thing to match on, right? And so there's a fair amount of capability that you can do with the simple match things, and yeah, now we're back into the business of, well, we're not talking about general purpose computation in here, so there are limits to what you can do, but the basic capability is there.
Right. Okay, good. Gotchas. All right. Yeah. Flynn, you want to talk about the gotcha?
Yeah. So William mentioned that service profile is going to be around for a little bit. And the biggest gotcha with the dynamic request routing in 2.13 is that the service profile and HTTP route do not compose. So having an HTTP route that routes traffic to something and then a service profile does other things to it doesn't really happen. If you have a service profile and that service profile defines routes within the service profile, it's going to win over the HTTP route. And this will be the case for the foreseeable future. The plan is, rather than doing all the complex work of making them compose, the plan is to arrange it so that HTTP route can just do all the things that service profile gets to do, and then you don't need to have service profiles for that. As usual, I am always enjoined from talking about timelines, although I could bounce that back at William, but 2.13 is still pretty early days for the Gateway API and Linkerd, and there are definitely things that will be changing over time as we go forward here.
Yeah, and if you're familiar with service profiles, they do kind of a lot of the stuff that HTTP route does, right? Like here's a regex or here's a pattern match across routes and stuff. But these things were designed, 3 or 4 years ago before HTTP route was here. So yeah, they'll live together with some caveats for 2.13, and then we'll see where we land up with 2.13.
There's a question from Dan Williams on Slack about using service profiles to collect metrics per route. Should you migrate to HTTP route if that's what you want? Kind of hate to say it, but probably not in 2.13. There's a lot of metrics work that is still on the horizon for HTTP routes, and I do not know if we currently think that's going to make it into 2.13 or if there's some concern about it not making 2.13. So I'd say hold off for now. Keep an eye on that.
Yeah, that's a really good question.
Yeah.
Actually, I have one more point I want to make here before. Is this the end of the dynamic request routing stuff? Are we going?
I believe it is.
Can we go back to like one of the examples? Because here's something that I had to wrap my head around a little bit, which is this policy that we're describing as routing policy. We're describing it in the context of kind of a destination, right? Like we're describing it in the context of this smiley service or in the context of this color service.
I decided to back up to color just to get the header matching thing off the screen, right?
Sure. But the behavior that gets modified by this is not the behavior of the pods on the smiley service, but is instead the behavior of the pods that are calling the color service, right? So this is a client-side policy. So even though we're defining this on the server side, right, we're talking about this as if it were a property of the color service, the actual behavior is only modified on the clients that call this thing. So that has a couple implications for you, and if you think it through, like in retrospect, yes, it makes sense, but it's a little strange. But one implication is if you have non-meshed services calling the color service, and they're not going to have this behavior, right? So this is only going to apply to meshed services that call the color service.
That's actually an excellent point. Now, chances are good if color is meshed, then non-meshed clients trying to talk to it might not work anyway. But yeah, that is an excellent point.
It should work. In my opinion, I don't think Linkerd interferes with that stuff.
Well, you
But
might have it turned off. I mean,
yeah, you should mesh everything anyways. That's my
well,
opinion.
absolutely. Come on.
But this is different from the authorization policy, right? I've been making this analogy between these two things. They both use HTTP routes, but the authorization policy stuff, those are server side. That's server side policy, and this is client side policy. So if A talks to B and both are meshed, you can kind of ignore it. If one of the two is not meshed, then you may have to think through, okay, is Linkerd going to do, is Linkerd actually going to be able to execute this policy?
And to reiterate William's slightly but not really tongue-in-cheek point there, it actually really is a lot simpler to reason about everything if you just mesh everything, which, I mean, obviously we're biased and we think you should mesh everything anyway, but this is yet another reason why it becomes more important.
Yeah, mesh or die.
Yeah, pretty much. All right.
Michael asked, is there any documentation specifically on the dynamic request routing?
There certainly will be. I don't know how much of it is published yet.
There's documentation on HTTP route. There's documentation for Wazoo for HTTP route, and that's probably where you'll spend most of your brain juice. But how do you actually wire that? Like the parent refs and stuff like that. Yeah, it's coming real soon.
Yeah. One thing that I would like to point out here, since we're talking about parent ref and such, is that if you look at a lot of the gateway API documentation, they will always show an HTTP route with a parent ref of a gateway, and we are using a parent ref of a service. That is not an error. We are deliberately, the parent ref of a service is actually the way this works when you're configuring it when you're using an HTTP route to configure Linkerd. And this is some of the stuff that's happening down in the Gamma working group that William talked about. All right. Let's move on. Oh, actually, I take it back. There was this other bit. William, you want to talk a bit about this buoyant cloud?
Oh yeah, I just put this in here because and actually I was trying to find a fancier screenshot, but I made this offhand comment that HTTP route is complicated. A lot of what we've tried to do in Point Cloud is describe describe what this thing actually does. So this is an example of authorization policy. This isn't dynamic request routing, right? But this is like, okay, I have this authorization policy, this HTTP route, and the server object, and they all relate in this weird way. How do I actually, what does that actually mean? So here we're trying to show you, okay, look, the way you've configured this, you have made a policy so that on port 7777, HTTP route that matches all the following conditions will be allowed only if blah, 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 blah. So we're going to do similar stuff for the dynamic request routing. I think life is very easy when you have one HTTP route. When you have like 17 of them and their backend refs are all whatever, life gets complicated. And that's kind of the trade-off that you make with HTTP route. It's very flexible and expressive, but you're basically doing a big old
distributed routing table.
Yeah, it's like a big old SQL join, across 7 different tables, and you're expressing it in YAML. So, all right, it's like you're going to need tooling at some point.
That's a very evocative metaphor. Yeah,
that's kind of what it is, right? It's like database joins in YAML.
But yeah, the tooling,
you start referencing, having to cross-reference, CRDs.
Yeah. All right. And that brings us into circuit breaking.
Yeah. So the goal here is stop sending traffic to a dying service, because sending it, all that traffic might actually be making it worse. And it's kind of like, often dying means that it's slow to respond. So then the client gets slow. There's all sorts of reasons why you might want to shut this off. So circuit breaking in 2.13, this has been coming for a long time. Basically, we're going to detect when an endpoint is failing, and then we're going to stop delivering traffic to it. And Linkerd, of course, knows when something's failing. We'll know when the success rate is too low. We'll know when there's too many consecutive failures. You can parameterize this in like whatever way makes sense for your service. Of course, part of that is when the service starts to recover, you should send traffic back on. And that's, non-trivial to do. But don't worry, Linkerd's here. And we're going to configure this for now with annotations. I think there's more to do here, and it's not entirely satisfactory. So in 2.14, we'll probably start looking, or maybe even point releases, we'll look at other ways of giving you a little more control. But annotations are very easy and simple and straightforward right now. So that's what how it's going to land in 2.13. Flynn, you want to walk through some examples here?
I should probably start by emphasizing the last point here, that this is not in Edge 23.3.2, which is what we're working with. So all of this is subject to change. But yeah, the idea is that you'll have annotations where you get to say things like, oh, after this many consecutive failures, then consider this one to be dead and break the circuit to it. Or if the success rate drops too low, and then you'll have a way to talk about how long you want to go after you kill it. How long do you want to go before you try it again and see if it's recovered? So there's a family of these things that will probably look something like this. But again, none of this is set in stone yet, so all of this is definitely subject to change.
Yeah, this feature's coming in hot, folks. It's,
very, very hot.
The core is there. The configuration like nuances are still being written as we speak.
Yep. Actually, I think literally as we speak, right this very moment. All right, health monitoring and stuff.
Oh yeah, so this is something we're doing as part of 2.13, and I'm kind of excited about this, but it's a little, it's a little different from some of the other features, which is, the goal here is, well, we've realized that a lot of people don't upgrade Linkerd. and in fact, we also know that a lot of Linkerd users have no way of knowing, when there's a vulnerability, right? There's no way, if we find a CVE or someone else finds a CVE, even if it's in some underlying library, we can tweet about it, we can make a blog post, but a lot of people just aren't, like that. They don't have a mechanism. And I think that's a real problem, because the whole point of Linkerd is we're trying to make this, thing secure and reliable, trying to give you the tools to make your system secure and reliable. So I can sit here and yell at you and say, please subscribe to this mailing list or whatever, but I think that only goes so far. So what we're going to do instead is we're going to make Buoyant Cloud have a free tier, which is, limited in a bunch of ways, but which is going to take on the kind of core task of making it easier for you to upgrade Linkerd, right? Because it can be annoying, making it very clear, when there's a vulnerability, and giving you the ability to alert on that, and then giving you some health alerts too, right? So that's all going to be free up to, 5 clusters or something, no limit on users, just trying to make this very lightweight and easy to use. It's going to monitor, things like certificate health and like control plane health. If we detect a CVE, it's going to send you a little nastygram, which has happened in the past, right? So like, don't think this stuff doesn't happen, right? Linkerd, like every piece of software, is built on approximately 7 billion underlying libraries, and each of these does very complicated things. And yes, we write it in Rust and all that stuff, but like, software has issues. Going to make it so that the data plane proxies will upgrade automatically when you upgrade the control plane, because that's kind of like toil. Will help you with TLS rotation and things like that. So really excited about that. Up until now, except in the very early days, Buoyant Cloud has been like a paid only product. So we're going to make this free tier that I think will be really useful for you. And I encourage you to do this. I think this is going to be an important part of operating software. If you care about security, if you care about reliability, you need a system to help you, make sure you're up to date and to notify you if something happens.
It actually is pretty cool to go and play with Buoyant Cloud after getting used to Linkerd Viz. There's some really cool stuff in Cloud, all told.
Yeah, but you're not going to have access on the free tier. Sorry.
Well, it's still cool to go and look at it.
Yes, it is.
Yeah. And its ability to get rid of some of the toil in particular is a really nice thing. If any of you have tried to keep a Linkerd cluster happy and healthy for the long time, or for the long term, there's it's actually kind of terrifying to look at how old some of the Linkerd installations in the world are. So please go and upgrade, people. It'll make us all feel better. Oh yeah, and there we go. I totally forgot the screenshot was here.
Oh
So
yeah. Just to give you a little visual, I was going to do a demo, but like, it's not really that. We get 90% of that from the screenshot. So, automated data plane upgrades, great. We'll give you some kind of basic visibility across all of your clusters of what Linkerd is doing, health monitoring, and then you can hook this up to Slack or to email, and just get alerts, if there's something that you need to look at ahead of time, like, oh, your TLS certificate's going to expire in 30 days, or, hey, there's a proxy that is like, continually ooming, or, even basic stuff like that. So
yeah.
we want to make it very easy for you to run Linkerd and feel safe about it.
FIPS.
Okay. Yeah. Now, all right. So if you need to run Linkerd for the U.S. government, this will be interesting to you. If not, then it won't be. What is FIPS? It's a compliance thing. My opinion is that it's worse for security because it restricts the crypto like libraries and algorithms and things that you have to use. And like these things got written down in some government document a long time ago. And what Linkerd does today in open source, I think, is significantly better than we have to do to make it FIPS compatible. But sometimes, you're selling stuff to the government and the government says you can't do this unless you obey our rules. So we have a commercial offering, which has got a FIPS version of Linkerd, and I would encourage you not to use it unless you have to satisfy these compliance rules, in which case you have to use it. And that's really all there is to say about that.
Just in case anybody was curious, if there was ever a time where William would recommend you not use Linkerd, you heard it here first, right? Don't use the FIPS for all the rest.
You should use
it for
Linkerd.
compliance.
Just, yeah.
All right. Anything else you wanted to throw in about 2.13 before we start talking about the workshop and demo?
I don't think so. We're going to write this all up in a big old announcement blog post. And like I said, we'll all be at KubeCon. We'll be at Linkerd Day. We'll be on the Slack. So, just hit us up and, let's deploy a beautiful service mesh together.
Sounds good. All right. Let's talk a little bit about the demo. I think many of you have seen this demo architecture before, but I'm going to go over it quickly to make sure that everybody's on the same page. We start with a cluster. This is the Faces demo. We have a Faces GUI. It's a single page web app. It reaches over and calls this face service. The face service in turn calls the smiley service and the color service. The smiley service should always return a smiley, and the color service should be returning a green color. The face service will composite those two together and then hand it back to the GUI, and the GUI will be calling this to show you a grid that should be happy, green, smiling faces all the time. We also have the smiley2 service, which returns a smiley with heart eyes, and the color2 service, which returns blue instead of green, but nothing is talking to them in the beginning. We have an Ingress controller. We're using Emissary. Which one we use is totally irrelevant for this demo. And we are, of course, using Linkerd to mediate all the communications between all of these workloads in our cluster. And with that, it is time to find out if the demo gods are going to smile upon us. So everybody keep your fingers crossed. We need to start off using the current Edge release of Linkerd, since this is not out in the stable 2.13.0 has not yet been released. But Edge 23.3.2 has been released, and it has all the cool stuff we want to play with here. So we're going to start by installing that Edge, and then we can make sure that our cluster is okay to install Linkerd and everything looks good. None of this install process has changed since Linkerd 2.12. You install the CRDs first, you then go through and install Linkerd proper, and then we'll use Linkerd check to make sure that everything is really going to be happy. And William, while you're doing this with your camera off, I'm going to, actually, you know what? I'll just let William stay there with his camera off. Now, of course, would be a great time, if you have questions, to toss them into the Slack workshop while we're waiting on Linkerd to come up. Because other than that, it's pretty much just, sit here and wait for Linkerd to come up. There's a lovely question here. Can we install the Edge using Helm? I don't actually know the answer to that. Do you know the answer to that, William?
Yeah, you should be able to install the Edge with Helm.
Awesome.
Yeah. And I'm here and listening in. I just figured people didn't want to see my face.
I was considering turning off your view on Restream, but I realized that if I did that, you wouldn't be able to jump in and answer questions or heckle. So that seemed kind of rude.
I'd never heckle.
Of course not. Absolutely.
Why is your computer so slow, Flynn?
Yeah,
Why does it take so long? Is Linkerd slow?
Linkerd is not usually terribly slow. Running Linkerd in Docker on a VM on a Mac, that's a little bit interesting sometimes. Okay, we've got Linkerd installed. We've got Linkerd running. I'm going to go through and install the Faces demo. I'm going to go through this part pretty quickly. It's there in the repo if you want to look at it, but a lot of this is fundamentally just the kind of toil that we often skip for these demos. I'm doing it live right now, partly so that you know that I don't actually cheat about all this stuff, but also partly because I really wanted to show, hey, you need to install the Edge here, and then go through and talk about the way the Edge pretty much works like the normal stable releases do. So at this point, we're just waiting for Emissary to come up at this point and be ready, which, shouldn't take too long.
Why is Emissary so slow?
Yeah, because
Sorry,
because liveness and readiness probes are annoying. That's why. All right, so that bit with adding some emissary mappings is about giving us access to get into the cluster at all. And now we're going to go through and install the Faces demo itself, which we will do by running inject and piping that into kubectl apply so that the Faces demo comes up inside Linkerd from the get-go. And we also have some mappings to give us access to specific things within Faces. So I'm going to wait for the Faces demo to start running. William's next question is going to be, why is the Faces demo so slow?
Why is Kubernetes so slow?
Why is Kubernetes so slow? Why is all of this? Why are computers so terrible? Yeah, they're less terrible than they used to be, I think. Or maybe they're just terrible more quickly than they used to be.
I think the hardware's gotten a lot better and the software's gotten a lot worse.
I would kind of love to disagree with you on that, but I'm not entirely sure I can. One of the interesting things that happens here is that condition available on the deployments will say that everything is ready before we get to the point that it's happy to actually really talk back to us. So that's what I'm doing right now. But I'm going to call this good. And we're going to go on. All right. At this point, we want not one, but two web browsers to show the Faces GUI. One of them is going to be completely normal, and the other one is going to set the X Faces user header to the value test user, like we showed earlier in there. And in fact, here are our two browsers, and we can see that this one says user unknown, meaning it's not sending any X Faces user at all. And this one is in fact sending the test user value. I don't know how easy it is to read those, but that's what they say. And you'll notice that both of these right now are showing exactly the same thing. They're just, showing a lot of green smiley faces, which is good. So I should also probably point out that the Faces demo application is deliberately designed to be kind of horrible. So it's possibly going to crash and restart in the middle, and that's how you know we're doing it live. Canary routing. We talked about this earlier, where we talked about how we can take this traffic going to the color service and we can split it. So 90% of it we're going to send to the pods that belong to the original color service. And the other 10% we're going to send over to the color pods belonging to the color 2 service. And remember that color is going to hand back green, color 2 is going to hand back blue. So if this works, we should immediately see some of these smiley faces show up on blue backgrounds instead of green backgrounds. Other things that are relevant, we mentioned this before, but just to reiterate, this HTTP route is going into the Faces namespace because that's where all the stuff for the Faces demo lives. And these are all saying port 80 because port 80 is what's defined in the service resource for the color service and the color 2 service. It is important that you get that stuff matched up correctly so as to avoid confusing pretty much everything. So let's go ahead and apply that. And we should immediately start seeing some blue. I will leave it to the interested reader to determine how many blue faces we should see out of 16 fields if we're doing a 10% blue split. But that looks kind of, on the order of what I would expect. And if you look at this, going back to the demo architecture, what we're changing here is we're basically just adding another line so that now sometimes when face goes to talk to the color service, it's actually going to get the color 2 service. The other interesting thing here is, let me point out, a lot of the time when you talk about Canary deployments, people are always talking about it happening at the Ingress controller. In this case, we're doing this down in the call graph, far away from where the Ingress controller can have any impact at all. This is all happening in the service mesh, and it's all happening without making any changes to the application at all. All right. The next thing we can do over here is we can actually edit this resource on the fly. So instead of doing a 90-10 split, we can do a 50-50 split. It's not actually important that these numbers add up to any particular value for the record. I tend to like them to add up to 100 because it makes it easier for me to reason about things when I glance at it. But we could have done 5 and 5 or 1 and 1 or whatever. So if we write that out, now suddenly we should be getting about half of these on blue backgrounds. And again, you saw how long that took after applying the thing. It happens basically immediately because the mesh instantly changes what's happening under the hood. Another thing that's a little bit interesting about this is we can actually change the weight to 0 and cause none of these to get green backgrounds. Now everybody is going to get blue backgrounds. We could also have done that just by deleting that backend ref entirely. But the cool thing about being able to set the weight to 0 is that it's much, much easier to use patch operations to alter the weight than it is to delete and re-add backend refs. And so if you're thinking about, oh, how can I automate this sort of rollout using tools that are only available in Linkerd, well, there you go. All you really have to do is change the weight in an HTTP route, and it's done. Okay, let's see if there are any questions about Canary stuff here before we go on to the A/B test thing. Is the percentage determined per client, as in 10% of connections go to color 2 is per client or across clients? First off, it's 10% of requests, not connections, which is important, especially when you're using things like HTTP2 and gRPC, both of which multiplex multiple requests over the same connection stream. And broadly speaking, it's each of the Linkerd proxies will be making that determination. So it's across all of the clients that are connecting to that. What's the right way for me to phrase this one? Since it's a percentage, it's going to be effectively global, but it's actually being computed per proxy. That's probably not the best answer, but that's the best one I've got right there. There's also a question about node ports and Ingress controllers. I am going to come back to that towards the end rather than addressing that right now. Okay. So let's go on and take a look at A/B routing for a second as well. This is kind of the second really straightforward type of dynamic request routing we can do. And we talked about this before, where we were going to use the xfaces user header as a match so that we could switch traffic depending on whether that header was present or not. And we have one browser window where it is present and one browser window where it's not. So what we're going to do now is talk about an A/B test where we want test users to get hard-eyed smileys instead of normal smileys. And right now, you can see that both of our browsers are showing the same thing, but we can talk about using an HTTP route on the smiley service so that if we see a match so that the xfaces user header has the exact value test user, it will get routed to pods belonging to the Smiley 2 service. If not, the default case, it will go to pods belonging to the Smiley service. So we can apply that And as soon as we apply that, the back window should immediately start getting hard-eyed smileys. Again, no changes here to the application. We just are changing where that traffic is going based on whether there's a header there. Again, the smiley service,
Amazing.
and again, the smiley service is down below the ingress's level. The ingress, trying to do an A/B test with the ingress would not work here. There is the important caveat that for this to work, Linkerd has to see the header. So the services need to pass that header on through. This is a pretty common sort of thing, pretty common sort of requirement as you're trying to do A/B testing in any sort of rich way. It's not usually that big a deal, but it is something to be aware of. All right.
Yeah, same. It's the same issue with like distributed tracing and everything else. You know, you're going to have to propagate these headers to do, if you want these features 6 layers deep in the call stack, you got to propagate the headers, and depending on how you've written the application, it's either really easy or really hard.
Yeah, so hopefully it's really easy. But yeah, it's an important thing. If you want to be working with information, then that information has to be available. William actually said something about this very early on that I wanted to point out as well, which is that you do get to do things like, if you need to do special computation and such, you do have the option of having the bit of your application that cares can do the computation and then inject headers into its requests going downward, so that you can use simple selection mechanisms at the dynamic routing and get very, very complex things to happen.
Yeah, like for the cookie example, like you could
Right.
have the ingress layer parse the cookie and then put, whatever the interesting bits are in, your own custom headers,
Yep.
and then do routing based on that. That's probably what I would do.
Yeah, and that's a not uncommon thing to see done.
Or you could lobby the Gamma initiative to add base 64 decoding as a core part of HTTP route.
Or you could lobby the Gamma group or the Gateway API group to arrange it so that there's a matches primitive on cookie values. That might also work. In this particular case, at the end of the A/B test, we can just go through and delete all this stuff. This is mostly showing how we can override 100% of the traffic here. So once I go ahead and write this out and it's applied, then we will see everybody gets hard-eyed smileys, whether the header is set or not. Now, is this a good idea, what I just did here? What I just did was I arranged it so that the face service is calling what it thinks is the smiley service, and then Linkerd is routing that to smiley 2 instead. Maybe that's a good idea. Maybe if you want everybody to have hard-eyed smileys, you should really go and change the smiley service. But, maybe that's not possible from an operational point of view. Maybe this is a case where it's not that you want everybody to have hard-eyed smileys. It's that your normal smiley service, for whatever reason, just started crashing. And so it's 8 p.m. on a Friday night. You don't want to have people working overnight. Stand up a new service and route all the traffic to it. And then that'll get you through the weekend until your developers come back and, have enough coffee to fix it or whatever. So this is an area very much where having the additional operational controls doesn't free you from needing to think about how it ties into your business processes, but it does give you an enormous amount of flexibility as to what's going on and what sorts of things you can do. And I believe that is it for the demo or workshop. I believe that does also give us some time for Q&A. In the meantime, as always, you can go ahead and take a look at the source if you want to, and we will happily be reachable on Slack too. So, any questions that we see showing up?
This is definitely a Flynn demo because of hard eyes. If this was a William demo, it would have been like
Skull faces and things like
emojis
that.
or something. So this is why we have you do that. One of the many reasons.
If it makes you feel better, I can go back and tweak it so that it's angry faces or something.
No.
There are
enough of that in this world today.
There are cursing faces in the normal demo. Actually, you might be happy about that. Circuit breaking annotations will be at a service level. I actually am going to hope that one of the engineers answers that one, because I can't remember if it's done at services or if it's done on deployments right now, which makes me very embarrassed. Oh, good. Alex answered. Let's see. Alex believes they're at the service level, so we will assume that Alex is correct and I am not. But
she's normally correct.
Normally she is, yes. We're not going to do Service Mesh Academy in April because of KubeCon. The May Service Mesh Academy is going to be a much deeper dive into circuit breaking and dynamic request routing and things like that.
Well, so then, Dan Williams has an interesting question. Can we do this for egress traffic? Would it work? Would circuit breaking then work if you made a external service or whatever for external name for some external endpoint? Does that question even make sense?
The question makes sense. I don't know the answer, but Dan, we can find out the answer. The question definitely makes sense, actually. I think we might have to do something. Like, the way we deal with mirror services or something, but I don't know. We'll have to look into that. So yeah, Dan, we'll look into that.
Yeah.
While we see if there are other questions, I'm going to skip ahead on a couple of things as well.
So in May, so you said April we're skipping because of KubeCon. In May, we're going to kind of revisit this content, but at that point the release will be out. A lot of these questions will be very concrete, and we'll go into some of the real deep, gory details. Today was kind of like
the whirlwind overview.
Yeah.
While we're waiting to see if there are more questions, I definitely want to call everybody's attention to Kube Crash, March 29th and 30th. It's virtual, it's free. We've got a bunch of cool talks that are happening there. March 29th is Zero Trust Day, and March 30th is Innovation Day. If you go to kubecrash.io, you can register, you can look at the schedule, you can do all your Kube Crashy sorts of things there. I'm kind of looking forward to that. There's a bunch of cool stuff there.
And it's not Linkerd specific, but there's some Linkerd stuff in there, and it's like people's, people in the cloud native space talking about how they use their source projects.
Lots of non-Linkerd stuff in there, actually, and lots of Linkerd stuff too.
Plus super evil megacorp.
Which, I mean, how can you turn down super evil megacorp?
We should have named Buoyant.
William talked about Buoyant Cloud. We should probably update this slide with the free tier coming out. But
that's
now,
right.
You can go to buoyant.io/demo and get a demo of it, and we will, in the big honking announcement blog post that is getting put together, we will have information on how you can go over and take a look at the free tier. What else? Service Mesh Academy, May 18th. Circuit breakers and dynamic request routing deep dive. Some of that is going to end up looking a lot like this workshop did, but there will be a lot more corner cases that get explored and a lot more stuff going on in there. And also, as we mentioned, we'll be doing that with 2.13 stable rather than with the Edge release.
Better answers all around.
Yeah, better answers all around. Okay, I am not seeing any other questions at the moment. If people do have things that they want to come up with or that they end up wondering about after this, once again, this is how you can reach me or William, or you can just show up in the workshops channel on Slack and ask your questions, and that always works. Anything else you wanted to add there, William?
The only thing I'll say is mesh or die.
Pretty much. All right. Thanks much, everybody. We're going to go ahead and drop this one off. We'll be back in May. Hope to see y'all at KubeCon.
Thanks, folks.
And at Kube Crash. Thank you.